Welcome to another class on oxidation and reduction. Oxidation and reduction. Don't forget, we have a lot of definitions under these oxidation and reduction. But we are going to look at those definitions and some aspects, and we end this class. The first one, we can define oxidation and reduction in terms of oxygen. Now, in terms of oxygen, what is oxidation? Oxidation is addition of oxygen. Addition of oxygen, but reduction is removal of oxygen. Now, when we are saying addition of oxygen and removal of oxygen, now take note, if you have something like this, carbon in solid plus oxygen as a gas will give us CO2 form of gas. Now, if you have something like SO2 to give you the solid, the sulfur, then plus O2 in form of gas. Now, if you check this very well, there is addition of oxygen here to this carbon to give CO2. Then if there is addition of oxygen like that, we call it oxidation. Then if you check this, there is liberation of oxygen. That is, there is separation of oxygen from sulfur. Because initially, sulfur and oxygen were together, but there is separation, and this separation will, this is a product side, this is a reactant side. So at the product side, it happens that there is separation of oxygen from what? From sulfur. So because they were together initially, so there is separation. So, and if there is a removal of oxygen like that, we call it reduction. Now, I believe you are able to get this one. Number two. In terms of hydrogen, we have oxidation to be removal of hydrogen. We have reduction to be addition of hydrogen. Now, for instance, if you have C2H4 plus H2 and you have C3H6, for instance, to give you C2 or C3 H, or let me even say C3H4 plus H2, or better still, you have C3H6 to give you C3, that's 3 times 2, that's 6. You have 3 times 2, that's 6 minus 2, that's 4, yes. This one here is 18. Now, if there is addition of 18, this one will give us C2H6. Now, check this very well. And it will give us what? 18. Though I'm not going to that side. But all I'm going is that there is addition of 2 hydrogen here to this one to give you this. And if there is addition of hydrogen like that, we'll call it reduction. And if you see this, there is removal of hydrogen. Initially, hydrogen here happened to be what? 6. But we remove 2 out of the 6 that is there. So it's obvious at the product side. So if there is removal of hydrogen like this, then we'll call it what? Oxidation. So sometimes it is not complete removal of the elements or atoms. It may be partial, but if there is reduction of the atom, then we'll call it either oxidation or reduction. It depends on the term. So if there is removal of oxygen now, that shows it is what? If there is removal of oxygen, that shows it is what? Reduction. And if there is removal of hydrogen, that shows it is what? Oxidation. According to the definition I give you. Now, number 3. In terms of electron transfer, in terms of electron transfer, now electron transfer, it means how they transfer electron within themselves. Now, oxidation is loss of electron. So if there's any atom or any element or any compound that undergo that lose electron, then it's that means it's undergo oxidation. And we have reduction to be gain of electron. What am I talking about? Now, if you have something like magnesium to give you magnesium 2 plus 2 E minus, and you have something like magnesium 2 plus, or let me use copper 2 plus 2 E minus to give you Cu. Now you observe that this one is taking 2 plus. So 2 plus here is like we have the 2 plus here, and we have this 2 minus. That's 2 times minus is here, and there's 2 here. That's minus 2 to give you a 0. That makes the left side to be equal to right side. Don't forget that the oxidation number of unchargeable element is 0. So this one is 0, and here you have it to be what? To be 0 as well. So that's why it is what? It is balanced. The same thing with this. This one is also 2 plus minus 2. That makes it to be what? To balance. Now, but where I'm going is that the electron is at the product side. So since the electron is at the product side like this, so that shows that you separate electron from this. And that means it's what? Loss of electron. You remove electron from it. And loss of electron, I call it what? Oxidation. And this one, you added electron to this. That's why we can have this. So that means addition of electron now is called reduction. So if electron shows at the product side, it shows that it is what? It is removal of electron. Now that's number 3. Now, number 4. We can define oxidation and reduction in terms of oxidation state. In terms of oxidation state. Now, what is oxidation and reduction in terms of oxidation state? Now, oxidation is increase in oxidation number. Increase in oxidation number, but reduction is decrease in oxidation number. Decrease in oxidation number. What are we talking about? Now, let's say for instance you have the Cu to give you Cu2 plus, and you have Mg 2 plus to give you Mg. You know, I did not complete this. On the norms, I will have it to be, there will be 2 plus E minus here, and here as well there will be 2 plus E minus here. But this is where I'm going. You observe that the oxidation states of copper here is 0. Then to this place, from this place to this place is plus 2 here, but this place is 0. So that shows that, you know, from 0 to plus 2, that means there is an increase in number. And if there is an increase in number like that, that is increase in the oxidation number, they will call it what? Oxidation. But if you check this one is from plus 2 to 0 here. And if there is like that, so from plus 2 to 0, that shows there is decrease in the number. It's reduced. And that reduction is called, that process is called reduction. The number 5. Number 5 will be in terms of electronegativity. In terms of electronegativity. Now, in terms of electronegativity, what is oxidation? Now, whenever you want to define oxidation in terms of electronegativity, quickly remember the use of oxygen, because oxygen is negative electronegativity. So, and in terms of oxygen, we define oxidation as addition of oxygen. So, in terms of electronegativity, oxidation will be addition of electronegative element, whereby reduction will be removal of electronegative element. That's the difference. Now, if we want to check, we can have something like Mg solid plus Cl2 to give us MgCl2. And you can have something like 2FeCl3 plus hydrogen to give us, let's say, 2FeCl2 plus 2HCl. Now, see this very well. You observe that there is addition. This electronegative element, there's an addition of this element to this to give us this. Then, if there is addition of this, we can call it what? We can call it oxidation. And why this is reduction? Reduction means removal. If you observe that initially, this chlorine is with this ion here, then later there is removal of part of this chlorine. There is removal of part of this chlorine from this. At here it becomes what, 2, but initially it's what? It is, sorry, 6. Now it's 2 times 3, that's 6. But here it becomes what? 4. So there is removal of what? Of the chlorine, part of the chlorine here, which chlorine is electronegative. So in this process we call it what? Reduction. So removal of electronegative element is called reduction. Now, number 6. Number 6 is in terms of electropositivity. In terms of electropositivity. Now, what is oxidation and what is reduction? So this will be opposite of this one. So if you want to define electropositive, remember hydrogen. So oxidation is removal of electropositive element. Electropositive element, whereby you have reduction to be addition of electropositive element. Now let us check. Now, if you have something like this, let's say you have AgCl2 plus Ag to give us AgCl2 or Ag2Cl2, and you have Cu2Cl2 to give us CuCl2 plus Cu. Now you observe that this is an electropositive element, that's mercury. Now, this is added to this. Initially this mercury here is 1, but when it's added to this, it becomes what? It becomes 2. And addition of electropositive elements like that is called reduction. So this is reduction. And if you check this very well, the copper here initially it was 2, but later it's been separated into what? We remove 1 out of it. So remove some part of the copper. And removal of electropositive element is called oxidation. So this is the difference between oxidation and reduction. Now, let me bring back the initial statement so you can check through in terms of oxygen, in terms of hydrogen, in terms of electron transfer, in terms of oxidation states, in terms of electronegativity, and in terms of electropositivity. So if they ask you any question, I think you should be able to define oxidation and reduction. Now, the next aspect we'll be looking at is redox reaction. Now, redox reaction is the reaction that contains redox. So we have it to be redox. This stands for reduction and this stands for oxidation. That's the meaning of redox. Now, redox reactions are, or let me say, they are reactions that contain both oxidations and reduction. They contains both oxidations and reduction. That's what they mean by redox reaction. Let me give you an instance. If you have Cu2 plus Mg to give us Cu plus Mg2 plus, you observe that from here to this place and from here to this place, if you check through very well, the oxidation number of this copper here is +2, then coming to here to be 0, and for the magnesium here is from 0 to +2. And if you observe this very well, there is an increase in oxidation number here, and if there is an increase in oxidation number, we'll call it what? Oxidation. If you observe this one from +2 to 0, there's a decrease in oxidation number, then we'll call it reduction. Now, I will be explaining under this redox reaction, I'll be taking two things together. And what are those things? I'll be explaining what is oxidizing agents and what's meant by reducing agents. Now, oxidizing agents can also be called oxidants. They can be called oxidants. And reducing agent can be called reductants. Reductants. Oxidizing agent can be called oxidants and reducing agent can be called reductants. Now, if in any reaction, if you are given oxidizing agents, or if you are asked to find oxidizing agents, or if you are asked to find reducing agents, now take note, though we have some common oxidizing agents and we have some common reducing agents, but take note, whenever you are asked to find it, then you have to understand the fact that oxidizing agents are agents that oxidizes, or they are agents that oxidize other elements or compound in a given reaction, but in the reaction they will be reduced. Now, what am I talking about? Reducing agents are agents that reduce other elements or compound, but in the reaction they will be oxidized. What am I talking about? Now, if you have a reaction like this, plus B to give us C plus D, let's say you have a reaction like this. If from here to here is oxidation, and from here to here is reduction. Now take note, what you have here would be reducing agent, and what will be here would be oxidizing agent. Now take note, you pick oxidizing agents and reducing agents at the reactant side. You cannot pick oxidizing agents or reducing agents at the product side, because how will you know that a substance is reducing agent or oxidizing agent when you pick it at the product side? Now it shows that the reducing agents and the oxidizing agents already perform the ability or the function of being oxidizing agents or reducing agents at the reactant side. That's why you can have the products open like that. So that's why you have the oxidizing agents and the reducing agents at the reactant side, not at the product side. So if you go through this very well, you observe that The reaction that undergo oxidation is what I called reducing agent, and the reactions that undergo reduction is what I called oxidizing agent. So if you are looking for oxidizing agent in a given reaction, just check the elements or the copper that undergo reduction, that is opposite of it. If you are looking for reducing agent, just check the elements or the copper that undergoes oxidation. That's the scope about it. Now, but that's not the end. You have to understand the fact that oxidizing agent and reducing agent, I explained to you that if you are defining oxidizing agent in the reaction, the oxidizing agent will oxidize other elements. You can see that this oxidizing agent, we call it oxidizing agent because it makes this oxidizing agent makes this element to undergo oxidation. I will call this reducing agent because this reducing agent makes this to undergo reduction, and that is it. Now let us check more example under this. Now imagine you are given CuO plus Mg to give you Cu plus MgO. Now you believe with me that from here to here what happens, and from here to here what happens. From here to here, there is oxygen here initially, but there is no oxygen here again. If I say removal of oxygen, don't forget removal of oxygen, that's reduction. But here, there is no oxygen here, but oxygen is being added. And addition of oxygen is called oxidation. And that shows, since I know this as oxidation and this as reduction, that shows that this one that undergo reduction is my oxidizing agent. And this one that undergo oxidation is my reducing agent. So that is the difference between oxidizing agent and reducing agent. Let's see more example. Now, I will do one episode on the oxidation number. So I'll give you some laws of oxidation number. Now, let's see some examples. Now, what if you are given a reaction like this? Let me see. If you have zinc plus CuSO4 to give you zinc SO4 plus Cu. Now check this. From zinc, or let me say from this copper here to this place, what happened? And from here to here, what happened? As you can see, that even I can use only oxygen here. As you can see, oxygen, zinc alone is here, but later there's addition of oxygen to this zinc, also 4 oxide to this zinc, but there's addition of oxygen. And if you are talking about the addition of oxygen, that's what? That's oxidation. But here, there's removal of that oxygen from here. It's contain only what? Only copper. And that's what? That's reduction. And if I want to pick oxidizing agent, that means this one that undergo oxidation is my reducing agent. And this one that undergo reduction is my what? Is my oxidizing agent. Is my oxidizing agent. And that's different. Check through. Now, let's see more example. Now, if you have something like this, MnO4 minus plus 8H plus 5Fe2 plus to give you Mn2 plus 5Fe3 plus 4H2O. Now check this. From this Mn here to this place, what happened? And from this iron here to another iron here, what happened? If you observe that the iron here is 5 times 2 here, that's 10. This one is 10, but here is what? Is 15. Even if you check the charge, there's an increase in the charge here. From plus 2 to plus 3, that's an increase in the oxidation state. And if you are talking about increase in oxidation state, then we'll call it what? Oxidation. Increase in oxidation state is oxidation. But if you check here very well, if I tell some people that this is decrease in oxidation state, some people will say, here we have -1, but here we have +2. No, that's not. What you are going to do is that what you have here is the oxidation state of manganese. So the oxidation state of manganese here is +2. So you are going to check the oxidation state of manganese in this whole equation. So let us see. We have MnO4 minus. So let us solve for the oxidation state of manganese here. Let's represent the oxidation state of manganese here to be X plus this 4 into bracket. The oxidation state of oxygen is -2. So we have -2. Everything equals to, don't forget the algebraic sum of the oxidation state must be equal to their charge. And what's the charge here? That's -1. The manganese here we represent it as X because that's what we are looking for. And oxygen, the oxidation state of oxygen is -2. But it has a subscript of 4. And everything equals to the what? To the charge, which is -1. So we have X minus 8 to be -1. So X will be -1. Then if you take this -8 to this place, it becomes what? +8. So X is equal to +7. So this place, the manganese here is +7. Can you see that from +7 to +2? That means that the oxidation state decreases. And this is what we know as reduction. And that shows that this that undergo reduction is our oxidizing agent. And this that undergo oxidation is our what? Is our reducing agent. So I believe I've been able to cover the difference between oxidizing agent and reducing agent, and at the same time given the knowledge about the redox reaction and definitions on oxidation and reduction. But there are some common oxidizing agents and reducing agents that I want you to know. If you are talking about the oxidizing agent, you have to know that majority of electronegative elements are oxidizing agents. I repeat, majority of electronegative elements or compounds, they are oxidizing agents. So let me just give you some common example oxidizing agents. Some common example of oxidizing agents if it's not in the reaction. We can have O2, that is ozone. We can have O3, yes. We can have even hydrogen peroxide. We can have chlorine. I told you majority of electronegative elements. We can have fluorine. We can have KMNO4. We can have H2SO4, etc. So majority of electronegative elements, they are oxidizing agents. Now for reducing agents, we have the majority of electropositive elements are reducing agents. Majority of electropositive elements are reducing agents. Now you can have even hydrogen itself. Hydrogen itself can serve as a reducing agent. We can have carbon, we can have ammonia, we can have H2S. Yes, they can serve as reducing agents. We can have zinc, so etc. So these are common examples of oxidizing agents and reducing agents. Now at the comment section, I want to know the oxidizing agents and reducing agents in this reaction. If you have 2 Mg plus O2 to give you 2 MgO. Now let me know the oxidizing agents and the reducing agents in this reaction. And is this reaction redox? Let me know. Answer it. The first question is, what is oxidizing agent and reducing agent in this reaction? Number 2, or let me even say, the first question should be, is this reaction redox? So because this will lead you to the second one. The question is this reaction redox reaction? Now, if it's redox reaction, question number 2, then give it to me the oxidizing agents and reducing agents in this reaction. Let us meet at the comment section. God bless you. Thank you very much. Like, comment, and subscribe for more videos. God bless you.